Hello guys, how are you doing? Let me trust you're doing good wherever you are. Today, I'd like us to discuss about testing the CPU. Not only the CPU, we shall also talk about the GPU and the PCH. And when I say the PCH, it will be both the north bridge and the south bridge. In short, we are going to discuss about testing the short in the chipsets. Yes, I know sometime we end up announcing the motherboard is dead or the chipset is shorted or the CPU is shorted, yet we don't know how to test it. Yes, so right away we are going to use these various motherboards to test them. The CPU we are talking about is this chipset. This is the brain of the laptop. Yes, and I like us to know how to test them so that uh, when we confirm the laptop is dead, it is indeed dead because we've tested and we've verified and we've confirmed the CPU is shorted. Under the CPU, we have two main chipsets. We have the CPU itself, this bigger chipset here. Then we have this smaller one. This one is the PCH, and the PCH it contains the two main chipsets, that is the north bridge and the south bridge. And I believe in my last discussion we discussed about the north bridge, whereby we said the north bridge is the chipset which is responsible for all the communication between the CPU, the RAMs, and the high-speed component, that is the RAMs and the SSD. While the southbridge is the chipset which is responsible for controlling all the inputs. And when I say all the inputs, I mean anything you plug in, maybe the USB ports, the external mouse, the USB flash, and even the audio jacks, the speakers, the fan, all of those inputs you input into your computer, it is controlled by a chipset called the southbridge. So we are going to test them. Yes, we are going to use these motherboards. These are examples of them. Unfortunately, we do not have the motherboard which contains the GPU because I would love to have also the GPU in the bench, but I am so sorry. I don't know. I do not have any motherboard which has the GPU in it. However, I am going to use these motherboards to explain how to build the GPU also. This motherboard will have had the GPU if we had a chipset here. So this is the socket whereby we should have the GPU. The reason what makes me know this is the GPU because I have what is called the VRAM. Yes, every GPU chipset contains the VRAM. The VRAM is the video random access memory. This is the memory for the GPU, and you can see it contains empty sockets because we do not have the CPU in it. Yes, same case with which other motherboard. This one doesn't have the GPU, that is dedicated GPU. This one will have had the GPU here. You can see this empty space here. Yes, the manufacturer didn't solder in the GPU there. Yes, and then this one doesn't have, and this one also should have had a GPU there. Yes, I didn't say this one doesn't have the GPU. However, it contains the GPU internally. That is what's called integrated GPU. That's the GPU which is integrated within the Intel CPU. So, yes. So that GPU is called integrated GPU. Yes. Or rather, what you call Intel UHD GPU. Then this one, the GPU which will have been here is what's called dedicated GPU. But the discussion we are going to do, it cut across all the chipsets, including the GPU, the CPU, and the PCH. Right? Yes. Whether the PCH is separated from the CPU or it is integrated in the CPU, or the discussion what you are going to do, cut across all of them. So let's start with one by one. Let's I don't know which one should we start with. Yes, let's start with this one, which is below. We shall start with this one. So this is the motherboard for 840G5. So this is the motherboard for 840G5. It doesn't have dedicated GPU. However, it contains integrated GPU. So within this CPU inside here, we have the integrated GPU in. So this laptop uses the Intel UHD because it is integrated inside. You can see the dedicated GPU that is not present. Right? Yes. How do you test? How do you confirm that the CPU is dead? One, we could have a physical damage. Yes, we could have a physical damage. That is, you could see a crack on top of the CPU here. In this metallic part here, you could see it is cracked. Yes, if it is cracked, you could see that's a physical damage. Both the CPU itself or the PCH. When you see the physical damage, that is the chips. We can say that one is dead. Again, if it's not physical, you can feel it. Yes, sometimes you feel it. Why? Oh, when you plug in the power, maybe you plug in the adapter, then we see an orange light there, or even the white blinking. It doesn't matter whichever the light, or even if there is no light. But when you try to feel, when you touch this CPU this way, you will find that it is really, really hot. Yes. When you find this smaller one very hot than this one, it means that chipset is there. Naturally, this chipset should not be hotter than this bigger one. Yes. Whenever you find that this one is very hot than this, that one tells you this one is shorted. Right? Yes. Even if this one is hot, that heat should be distributed equally. That is evenly distributed all the way around on top of this, not one particular corner. Sometimes you find that one specific corner is heat emanating from there. That's also a problem. Yes, it should be getting hot uniformly, but not hot as much as not excessive, whereby you can't touch. Right? Yes, you need when you feel it, at least you can stay there for some time until you feel it's getting hot. Right? Yes, not the one you just place it and then you find yourself. It's like you touch a very hot metal, right? Yes. So it's something at least you can feel it until you feel like, how it's really getting hot. Then you can remove your hand gently. Not the one you just place it and then it's too hot. Yeah. Yes. So all the CPU, we could have the physical damage. That is number one. Number two, we could feel the heat from the PCH. That's also the side of dead CPU. Then what about in a situation whereby we can't feel the heat? Again, we need to be at least careful, or we wait, we be patient when you are feeling the heat. Sometimes you find that when you just touch this way, it is still too cold or just warm. At least you need to stay there for some time. Then you wait until you wait whether it will be a pinching. Sometimes you can feel it like it's pinching you. That's also a problem. That's a sign of shorted chipset. Yes, at least you need to wait. Yes, if you wait until you hear maybe let's say you wait for it to get hot, then after some time the heat just come and goes. Then you wait again, it come and goes. That's also a sign of uh, a bad PCH or the bad CPU. So it cut across all the chipsets. Huh? Yes, be it the southbridge, be it the PCH, be it the northbridge, be it the GPU, be it the CPU, all of them. So let's discuss now. How do you test it? Let's say we can't feel anything. Let's say we can't feel anything. How do you test it? One way of testing it is using a digital multimeter. One way, that is the simplest way, using the digital multimeter. That's the first one. Number two, if you have the infrared camera, that is thermal camera. That's also the perfect way of testing the CPU whether it is shorted. The cool thing about the camera, it is able to detect even the slightest increase in heat. It will pinpoint the emanation of heat within the chipset. If you see the heat is emanating from a particular corner or from a specific point, you could see it's just a specific point is getting hot. That still means that CPU is shorted. Be it the CPU, GPU, or the PCH. Yes, you need to see the heat emanating from the CPU and it should be uniform. It's not hot as the one which you can't touch it, right? Yes. So let's discuss about using the digital multimeter to test for the shorter CPU. Then I said the first thing you need to do, have your meter on. Have your meter on. Not only on, you should put your calibration lead with a continuity mode. So this is the continuity mode of my meter. Then I don't need the resistant mode, but also I can use the resistant mode. But for me, I like to use the pipping mode. That is the pipping mode, right? Yes, the continuity mode or pipping mode. You can see the bell icon there, and the laptop, the meter, not the laptop. I don't know why am I obsessed with the laptop. You can see the meter is right and what? OL. That is an open line. It means there is no continuity. So what we need to do is to have my probes. I have my two probes here. That is the black probe and the red probe. Yes. As you can see, when I put the probes together, it pips and it shows low resistance. That is 0.2. That means 0. That is 0.1. That's 0. So it means we have very low resistance. The lowest resistance, that is 0 resistance. Huh? Yes. So that means we have continuity there. So what you need to do is to put your plug probe on the ground, to put your plug probe on the ground. Then the other probe, you should put them on the power supplies to the CPU. Yes. If it is the GPU, you put another probe to the ground, then another probe to the power supply to that GPU or the PCH, whichever the power supply for the chipset. Then, what do you expect for a good CPU? Obvious, or the for a good PCH, for a good chipset. Let's say good chipset, because here we are discussing about the GPU, and the what, and the PCH, and even the CPU itself. So a good chipset, it should have pipping, of course, it should pip because we have resistance from that chipset. Again, it should have some resistance, not as low as 0, because here you can see I have 0 resistance, that is ground to ground. When I have a resistance which is coming close to that or coming to that, it means that chipset is shorted or that line is shorted. And there is no way that line is shorting to ground and it fails to short the CPU, right? Yes. I'll tell you how to confirm. Once we have that lowest resistance in that line, how do you confirm now that lowest resistance is coming from the CPU or is coming from the controller of that line? So as you can see, I have my probe there placed into the ground. Then my other probe, I should place it on these inductors. You can see these inductors. These inductors. These are the inductors which are regulating the power going into the CPU and the PCH. So let's start with this one. I say I expect to have pip sound. It should be pipping, and at the same time I should have low resistance if the CPU is good. As you can see here, it's pipping. Yes, the meter is pipping. I don't know whether you can hear it. I know you might not hear because the microphone is a bit far away from the meter. And again, you can see I have 14.2 ohms. That is 14.2 ohms. That means that line is okay. And you can see this line is going where? Inside the CPU. You can also place here on the main line, on the positive line of this capacitor. You can see positive line of the capacitor still reading 14.0 or 14.2 or 0.3. That means that line is okay. That line is very okay. I don't have problem there. In case I will have had maybe 0 or even as low as 0 and as low as 1.2, that's also alarming. That's a problem because that is too low. That's not the resistance for the CPU. So at least you should have more than, let's say, more than 3. Yes, more than 3 ohms. Even 3 is too low still. Maybe from 5 and above, I can say from 5, that's good. But when you find the resistance coming too low as 4 and below, that means that line is shorted. If it is 4, we can say maybe it's partially shorted. Something small is shorted. If it is 2 ohms, that's still very low. That's a problem. When it is 0, that means that's deadly bad. It's bad. Nice? Yes. So let's see this other power supply. This one, still pipping, and I have what? 10.3. Why am I having here 10.3 and here 14? Huh? Do you know why? Because this one is going into the main CPU, and this one is going where? Into the PCH. So this one going to PCH, this inductor is written R15C. All of them though, all of them are written R15Z. So probably these ones are for the PCH. So this one should have the same resistance as this because they are going into one area. They are going all of them to go into the CPU, so the PCH. So that one we said that's 10.5. What about this one? I say we should have almost the same. We should have the same. Also 10.5. So that means the CPU of this machine is very good. Are you getting? Yes, let me know if you're getting because I am discussing it for you. Higher. Looking at this. This one is reading 0.4. That means that is 0. So meaning the line whereby this power supply is applying, the line whereby this thing is going, is the one which is having the short. So inside this chipset, I didn't say the chipset. So this power supply, its line is good, not shorting to ground. This one is good, not shorting to ground. This one is good, not shorting to ground. But my problem in Wapi, my problem is here. My problem is here because I see I have the 0.0 something ohms. That means that line is shooting to where? Shooting to ground. Now, how do you know whether we? So, what I urge you to know, the output of these inductors. Yeah, for example, this. Let's say this. The input is here where there is a controller. This I see the controller. Let me bring it closer to you so that you can understand it very well. Because we might not repeat this information again. You can see this IC. So this IC is the one stepping down the voltage. So from this line, this is the main power line. The main power line is coming into this IC, and this IC step down that main power line into maybe 1 voltage or 0.8, depending on how much is needed to go past here. So if I have 19 coming this way, then this IC should step it down and then pass it through this inductor to be regulated and then sent to the CPU. So in this inductor, so this side of the inductor is the input, and the side of this inductor is the output. So in case I had the short, for example, this one, in this one, I have an IC here, so meaning the input side is this one. This is the input for this inductor. So I have the input coming this way, and the output is going this way. So here, the voltage is going past here, then it is sent to wherever it needs to go. Now, since I have lowest resistance here, I like to know whether the short is coming from the input or the output. That is, whether the short is from this side or this side of the inductor. So what do I do? In that situation, what do you do? What I will do is to remove that inductor. We are going to dissolve that inductor. Then once you have that inductor out, now we are going to test whether the side which is shorted is the input or the output. You know, the inductor is like a bridge. Eh? Yes, it is bridging the two lines, the two power lines. So, these inductors, all of them, these stacked inductors, not only stacked inductors, all of them, it is bridging this side of this, the input to the output. So, when you remove it, for example, as you can see this, so I had an inductor cutting across from here to this other side. So once I remove it, it means I left what? A gap. So there's a gap here in between. So there is no connection between this point to this other point. Let me hope you're getting it, because if you're not getting, you need prayers. Now let's check this inductors. We have the input, then the output. Let's see which side is shorted. One brought to the ground, then another to the input. You see, the input, I have no problem. Here is the input. So from this controller, from here and go back to the main power line, I don't have any issue. What about the output? The output is now where the power is going. That is the after here, after the voltage goes past here, it will go into the PCH, a particular point within the PCH, maybe the southbridge. Yes. So this after inductors here, which were going to the PCH. Remember, I told you maybe these ones are going to the PCH, but probably they are going to the northbridge. Then this one are going to the southbridge, and now these ones are shorted. So it means the southbridge for this motherboard is shorted. So the CPU itself is good, northbridge is good, but the southbridge is very bad, very shorted, because you can see the output here is shorted. Even if you can test this capacitor is connected to ground to power, and you can see it is having 0 ohms. So it also means what? It also means that line is shorted. That is the output of that light. So for me not to forget this inductor, we'll have to put it back because we might need it tomorrow. That's why we need to put it back. So we are going to put this one back. Then we discuss the other motherboards. Eh? So this first motherboard, it is good using it to make elaborate discussion on what we are going to test and how we are going to to test the short on the CPU. So I believe by now, at least you've understood how to test for the shorted CPU. The first thing, you do the physical inspection, whether you can see any crack on the CPU. The second thing, you try to feel whether you can feel some chipsets getting hot, whether the PCH or the CPU itself. Then, lastly, we said you need to be patient and wait. Sometimes you might hear the pinching. You would feel like it is pinching you. That's also a problem. If it is warm, you just have to wait which side is getting hot. Is it the PCH? Sorry for the noise. So for example, we have another motherboard here. We have the CPU itself and then the PCH. So I said you just have to be patient enough and wait to feel which side is getting more hot than the other side. If it is this side, you have to be very sure again. Is it even the distributor or a particular point is getting hot, right? Yes. Then from there is the topic of measuring whether we have the shorting to ground. We have the short to the ground. For example, we can use this one. So I believe these are the lines which are going to the CPU. This one, this big one, and I believe this one. No, this is the main one. This is the main one which is applying the CPU with power, and I believe even this one. So also supplying the CPU. Let's check. Let's test and see what actually is happening. Let's test and see what actually is happening. My meter there, I believe you can see the readings. We pay attention to the reading. We don't even care about the peeping, whether it's peep or not. What I'm paying attention to is whether I have low resistance or high resistance. So my probe to the, it doesn't matter which probe I put to the ground, because after all I am testing the resistance. So my probe to the ground, I say I expect to have some resistance, even though it's peeping. So let's start with this one. It's peeping with what? 9.1. That means it's good. What about this smaller one? This one also 17, and it's still peeping. What about this one? This one now is not peeping. So it means this one even is not connecting the CPU. So I believe here I have the two lines going to CPU. So I have for the CPU and the PCH. Period. If I had the GPU here, the same thing happened. I need to put my probe into the ground, then my other probe into the power supply for that GPU, or that southbridge, or that whichever chips that I'm trying to test. Right? Yes. Nice. Let's have a look at this again. I have another one here. This is for that G2. This is for that G2. Then the other one, the first one was 840 G5. Then here I have 1030. So this is 1030 G3. So this is 1030 G3. So let's have a look at again. Here I have the CPU. The CPU, I have the power supply for that CPU. Let's have a test these power supplies, whether they are shorted at the ground or not. I can't see any physical damage. Of course, this motherboard doesn't have the port, so it does the port. Huh? I do not. Can we plug into the, no, okay, anyway, so long as I have told you, you have to try and feel whether you can feel any heat. If you find that this smaller chipset is getting hotter than the other one, it means that one is shorted. Again, sometimes you need to be very careful, because sometimes you might feel that chipset is getting hot, and maybe that short is being transferred from a shorted BD controller of ERMOS from here. So you need to be very careful. Even though you felt there's a heat here on the southbridge, at least find out that short is coming from where. Is it this line? Is it this line? Or is it this line? Once you find you have a short coming through this line, at least disconnect that line by removing that inductor. Then measure, you see whether the short is the output or the input. If the short is coming from the input, that tells you that short which was getting maybe that CPU is lucky, because that heat which you are feeling from here might not be because this one is shorted, but because that line, a certain component was shorting that line, and it was transmitting that short to where? To here. But let me tell you, there's no miracle which can happen like that, because once you have the short coming through here, it means that 19 voltage has been allowed to go into there, into the CPU. Maybe by miracle that CPU can survive, but rarely. I have never seen it surviving. Yes, because that 19 versus the 0.9 which was needed, that's far away, far ahead of what was needed. So let's have a test. Let's test this power supplies. One put to the ground. Then let's start with this one. This one pipping with 3.6. That's not good. Our short is 0. This one 3.5. 3.2. Let me just give it benefit of doubt, but it is not good. Not good at all. 3.4. 2.5. 2.5. 2.5. Okay, I don't like these readings. At least here you can say I have 10 points. So it means these 4 lines of 6 of them are having something shorted. And it is not a miracle because now everything past here was receiving, that is a partial short. Because you have 3.4 against at least 5, which is needed. So here I have 10. Here is 10 ohms, which is good. Here 4, 3.6. I cannot comment on that. Okay, maybe to be sure, we can also use this one. This is another 1030, but this one was G3. This one is G4. Let's try and use this G4. Let's test this one G4. Let's try and use this one and compare. Those power supply which I was using before are these ones. So let's confirm with this. So ground. This one 5. Now this one at least it is having 5 ohms. That one is good. This one 5.3, and you can see they are the same because they are the same inductors. R12, all of them are the same. That's why the other one was reading 3, all of them were reading 3 because they were partially shorted. So this one 5, good. 3.7, not good so much. Not a lot. 3.6. What about this one which was having 10? Still 14. Then the last one, just some insulation. I don't know which kind of material is this one. Some more insulated. Anyway, but at least you've got some hint. So let's try this one. This is then 30. This is 830 G5. One probe to the ground. Let's see the power supply for the CPU. We start with this one. This one has been knocked out at this reading. Let me bring it closer so that you can see. Probe to the ground. Then to this side, 10 ohms. That's good. 6. That's good. This one is not the power supply for the chipset, so this one we can ignore that. 5. That's good. So here the CPU seems to be good. Yes. Then let's have a look at this last one. This one is for the Lenovo. This is the Lenovo. So this one is a gigabyte Lenovo. Let's so yeah, the resistance for this 3.5. Okay, maybe we can allow this 3.5, but we can't allow below 3. That is 2.5 or 2, because this one seems like we've gotten several ohms. In short, in the bottom line, I'd like you to have some resistance on the power supply going into the chipset, right? Yes, I like you to have some resistance on it. In case you find that you have very low resistance, that is 0 resistance, it tells you you have a problem with that chipset. 5.4. So guys, thank you so much. I don't know whether you're getting these things because I am trying as much as possible to explain and to feel like you're getting it. And if you're not getting it, I said earlier, you need prayers. Yes, you come with prayer together. Maybe you will understand. But sorry guys, sometimes I joke too much. So, but anyway, let me hope you understood some few things. It should be good for you. It is one way of you understanding if the chipset is bad or the chipset is shorted, and it will save you time to move on to the next case, right? Yes. Once you know how to test whether the chipset is shorted or not, it will be easier for you to move on. You will not waste time trying to fix something which is not fixable, right? Yes. So thank you so much, guys. And please, if you haven't subscribed to this channel, please, I'm still pleading with you, my guys. Please subscribe, share with your friends, and give us some comments. In case you are interested in learning about laptop repairs, you are highly welcome. You can join us. We do available offline, that is in person. You can come. We are teaching laptop repairs, and also we do laptop repairs. In case you have an issue with your laptop, you can send it to us, or you can bring it to us so that we can repair for you and send it back to you. Thank you so much, guys, and see you in the next video. Bye bye.